A critical part of the order fulfillment process is vehicle routing and warehouse provisioning. Each order is the delivery of multiple products, of stock keeping units. Each delivery, you need to decide from which warehouse to provision it from, which vehicle to use, and how to route those vehicles. This is both an inventory allocation problem and a vehicle routing problem. You can't solve one without the other. But if you optimize them together, you can increase your productivity by 25%. Let me show you how. Here we have a demo of our order fulfillment routing model. So in here, we have two distribution centers. One on the left, which has stocks of water, wine, juice, beer, and cookies. And one on the right, which has stocks of pastry, wine, cookies, and beer, and coffee. So the right one is the only distribution center that has pastries and coffee, and the left one is the only one that has juice and, I guess, water. Yes. So we need to decide for each of these deliveries which vehicle to send from which distribution center. So, for example, here we need to have some beer, obviously that come from either side. But for this order, we need to deliver pastry, and pastry can only be delivered from the right side because this distribution center has pastry, but the left distribution center does not. So now, what if this order would also need to have water, for example, and it does, then clearly it cannot come from the right side, it needs to come from the left side too. So in this case, we'll actually have two deliveries at the same location, at the same order, simply because we don't have a distribution center that can deliver both of these, or at least not one that's close by, and that would be a good idea to send it to. Now, let's solve it. So what I'm going to do is I'm going to click the solve button and we'll watch the driving time. As you can see, our solver is now optimizing the vehicle routing problem and the inventory allocation problem at the same time. At the top right, you can see how the solution, which takes the total driving time into account, gets better and better. As you can see, the solver is now optimizing this plan. There's a number of constraints that play into that. And one of the constraints is we want to reduce the total driving time. And that's the number you see there on the top right. We started with more than 60 hours of total driving time. That's the amount of time the drivers are driving in their vehicle, and we actually want to reduce that. So as we give it more and more time, you'll see this actually goes down to less than 40 hours, which means our productivity increases a lot. This is a huge cost saving for a company, but it's also good for the environment as we reduce the CO2 emissions heavily. Now, we can't just send any vehicle to any order, as I've shown before, and we have to take into account not just the fact that the distribution centers have the necessary stock keeping units to deliver there, but also that they have enough for all of the vehicles that are coming out of there. If we have two vehicles that need to deliver, let's say, 10 water, that's 20 water in total, but we only have 15 water in stock in one distribution center. Obviously, we cannot do both deliveries from the same distribution center. We would also need to pull in other distribution centers to make that happen. Okay, let's stop it. So now we have now we can actually solve this problem with less than 39 hours. What I didn't tell you, originally, some of the orders could not be delivered. Now, because we have a 0 medium score, and that's actually the number of undelivered orders, the number of undelivered order lines, all of the orders are actually fully delivered. But there's more constraints to this than what I'm showing. Let's first take a look at the stock levels. So here we have the stock levels. In this distribution center, we will deliver 29 out of the 50 water that's available there. We will deliver 32 of the wine out of the 50 wine that's available there. So if you look at the first order here on this route, this requires 3 wine, right? Over here, on this order here, we require some beer and some cookies. Here we require some juice. Here we require some beer. And so the total of all of those, for example, beer and things together, this is 2, that's 4 together. And then, of course, the other routes going from this distribution center, if those are, we need to deliver beer too, we sum those up. And the total of that will be, in this case, 15 beer out of a 200 is being delivered from there. The pastry is coming from the green vehicle on the right, and the water is coming from the left, from the yellow vehicle on the left. There's other constraints here at play. One of them is the time windows on the orders. So each order has a ready date and a due date. That means that there's only somebody there to open the door during those particular times. And we cannot deliver those orders before the ready date or after the due date. Some of these are quite flexible, as you can see, but others, like for example, order 2 over here, needs to be delivered in the morning. So that also limits our routes, and that might actually cause some of the routes to cross over each other. Something that I'm not really seeing here, but it would not be uncommon to have because of the time windows. If you're dealing with order fulfillment and you want to optimize your vehicle routes, your inventory allocation, optimize order picking, contact us. We can help.